Hello friends, welcome to our channel. Today I will discuss how to find out the plastic moment of a beam. So if we want to find out the plastic moment capacity of this beam, so first of all we have to know the number of the plastic hinges and where it will be formed. Okay, so if we want to find out the number of the plastic hinges, so we have to mind it. The number of the plastic hinges will be ds plus 1, where ds is nothing but degree of static indeterminacy. Degree of static indeterminacy. Okay, ds plus 1, ds plus 1. So now we know that degree of static indeterminacy is ds equals to r minus 3, r minus 3. So where is the r is the number of unknown reaction and 3 is the number of equilibrium equation. So in this case we will consider this equation as ds equals to r minus 2, because here horizontal forces are neglected. Suppose it's a fixed point. Okay, so here three reaction will act. This is the fy, it is the fx, and another moment m will act here. So in the case of the plastic analysis we will generally don't consider this fx. Okay, so axial force will not consider. That's why this equation will be ds equals to r minus 2. Okay, now for this beam, this is a beam, a point A is fixed and point B is also fixed, and a concentrated load, that is the working load. P is acting here, it is L by 2, and moment carrying capacity, the moment of inertia is same. Okay, so now here, so number of the plastic hinges will be, this is the, so we have to find out the degree of indeterminacy where first of all, so here r, d is the static indeterminacy, so r minus 2. Okay, so here number of the unknown force will be 5 minus, it will be 4 minus 2, it equals to 2. So degree of static indeterminacy is 2 here. So number of the plastic hinges will be, so number of plastic hinges will be ds plus 1, that is 2 plus 1, that equals to 3. Okay, now for this particular problem, for this case, for this beam, the number of the plastic hinges will be 3. So now we have to know where plastic hinges occurs. Okay, so number 1, moment of inertia is changing. Where the moment of inertia is changing, suppose it's a beam, it is a fixed beam, moment of inertia of this portion is 2i and this portion is I. So plastic hinges will form at the point where, this point, because at this point moment of inertia is changing. Okay, so here plastic hinges will form. Okay, number 1. Number 2, fixed support. At this point, fixed support, plastic hinges will also form at the fixed support. If any load acting here, that is under the point load. Okay, under the point load. And next, maximum bending moment. Suppose it's a simply supported beam having uniformly distributed UDL on it, W kilonewton per meter. So bending moment of this case will be maximum bending moment will be WL square by 8, and it will be at the midpoint, okay, that is the L by 2 from here. So at this point plastic hinge will also be formed. Okay, so now I will discuss how to find out the plastic moment for this beam. Okay, so in this case we know that the number of the plastic hinge will be how much? 3. So we know that plastic hinge will form at the fixed support and at the under the point load. Okay, so here diagram will be in this way, it will reflect in this way. Okay, so the moment carrying capacity suppose is MP. Okay, so now here load is acting here, so we will consider this load, it will be ultimate load. So that's why we have to multiply this load, that is the working load, suppose it is P. So ultimate load will be PU will be 1.5 into P. We have to multiply this value, the factor of safety. Okay, so we will calculate this moment for the ultimate load, not for the working load. Okay, so now I will discuss how to find out the moment. Okay, so to find out this find out the moment carrying capacity of this beam, external work done will be equal to the internal work done. External work done equals to internal work done. Okay, so here external work done, what will be? We know that external work done will be load into displacement. Here displacement is nothing but theta. Okay, so external work done I am writing here Pu into delta. Okay, and internal work done is nothing but internal forces and this displacement theta. Okay, so and we are seeing here 3 plastic hinges will form here, as this end were fixed, so plastic hinge will also form here, will also form here, will also form here. Okay, so now internal work done will be for this point MP into theta, plus for this point it will also be theta, MP into theta. For this point here it will be also theta, MP into theta. For this point it will also be MP into theta. So if we add it, it will come 1 2 3 4 MP into theta. So Pu into delta. So now we know the delta is nothing but delta equals to, here we know that tan theta equals to delta by L by 2. As this theta is very small, that's why we can write it as theta equals to delta by L by 2. So delta will be theta into L by 2. So we have to put this value in this equation. So Pu into theta into L by 2, it will be 4 MP into theta. Now this theta and this theta gets cancelled out, so here it will be Pu equals to 8 MP by L, or MP will be Pu into L by 8. Okay guys, so this is the value for plastic moment for this beam. Okay, now in my next lecture I will discuss the plastic moment capacity for the beam. In that case, one end will be hinged, or one end will be free and other end will be fixed. Okay, and the load condition will be changed there. Okay guys, thank you.